Hello everyone, welcome back to my YouTube channel. I am Yashashwini. Today in this video I am going to discussing about the subject mathematics and my topic is exponential distribution. First let us see about introduction to exponential distribution. The exponential distribution is a probability distribution that describes the time between events in a Poisson's process. It is characterized by a single parameter lambda known as the rate parameter. The exponential distribution is often used to model the time until the next event occurs. Exponential distribution, stated again, expect using time intervals the probability that an event does not occur within a specific time interval is. The formula of exponential distribution is P of capital T greater than T dash is equals to e power minus lambda into small t, where capital T is the actual time. Numbers will be given. Small t is the proposed specific interval divided by the time unit of lambda, where lambda is the average rate of occurrence. Probability density function. Probability density function of the exponential distribution is given by f of x is equals to lambda e power minus lambda into x, where x is greater than or equal to 0. The probability density function represents the likelihood of a random variable taking on a specific value. The exponential distribution is skewed to the right with a long tail. Cumulative distribution function. The cumulative distribution function of the exponential distribution is given by f of x is equals to 1 minus e power minus lambda into x, where x is greater than or equal to 0. The cumulative distribution function represents the probability that a random variable is less than or equal to the specific value. The cumulative distribution function of the exponential distribution increases from 0 to 1. Expected value and variance. The expected value of the exponential distribution is e of x is equals to 1 by lambda. The variance of the exponential distribution is variance of x is equals to 1 by lambda square. The exponential distribution as a memory-less property means the probability of an event occurring in the future is independent of how long it has already been since the last event. Expected value formula. E of x is equals to integration of a to b x fx into x dx. A is lesser than or equal to x, x is lesser than or equals to b. Exponential probability density function. Fx of x is equals to 1 by lambda into e power minus x by lambda. 0 is lesser than or equal to x, x is lesser than or equal to lambda, where the expected value of the exponential distribution formula is e of fx into x is equals to integration of 0 to infinity x into 1 by lambda into e power minus x divided by lambda into dx. Applications of exponential distribution. The exponential distribution is commonly used in reliability engineering to model the time between failures of the component. It is also used in queuing theory to model the time between arrivals of customers in a system. The exponential distribution has applications in insurance, finance, and telecommunications, among other fields. Relationship with Poisson's distribution. The exponential distribution and the Poisson's distribution are closely related. The event occurs in a Poisson's process with rate lambda, then the time between events follows an exponential distribution with rate lambda. The Poisson's distribution describes the number of events occurring in a fixed interval, while the exponential distribution describes the time between events. Parameter estimation. The rate of parameter lambda of the exponential distribution can be estimated using maximum likelihood estimation. Alternatively, the mean of a sample from the exponential distribution can be used as the estimator for 1 by lambda. There are also statistical tests available for assessing the goodness of fit of data to the exponential distribution. Hazard function. The hazard function of the exponential distribution is given by h of x is equals to lambda, where x is greater than or equal to 0. The hazard function represents the instantaneous rate of failure at the given time, given survival up to that time. The hazard function of the exponential distribution is constant, indicating a constant failure rate over time. Relationship with other functions. The other distribution is a special case of a gamma distribution where the shape parameter is equal to 1. It is also a special case of the Weibull distribution where the shape parameter is equal to 1 and the scale parameter is equal to 1 by lambda. The exponential distribution is related to the chi-squared distribution, which is the distribution of the sum of squared standard normal random variables. Limitations of exponential distribution. The exponential distribution assumes a constant failure rate, which may not be realistic in many real world situations. It does not account for wear and tear or aging effects that may increases the failure rate over time. The exponential distribution is not suitable for modeling events that are not memoryless. Stimulation and random number generation. Random numbers from the exponential distributions can be generated using inverse transform sampling. The inverse transform sampling method involves generating random numbers from a uniform distribution and applying inverse of the exponential cumulative distribution function. Stimulation techniques such as Monte Carlo stimulation can be used to model and analyze systems involving exponential distribution. Conclusion. The exponential distribution is a probability distribution that describes the time between events in a Poisson's process. It has a single parameter lambda which represents the rate of occurrence of events. The exponential distribution is used in various fields to model reliability, queuing, and other time related phenomena. Thank you for watching my video.